My name is Luis. I'm a math uh, autodidact student. I'm also an English student. I'm from Mexico, and in this video, I want to talk about uh, multivariable optimization. This kind of stuff that has to do with uh, Lagrange, Lagrange multipliers and that sort of things. And today I I'm coming up with this example. So what we are up to here is we want to maximize this function f equals x squared y squared on the set x squared plus y squared equals 1. So here I took this screenshot from Desmos, and the red function represent the function f. The function f I wrote here, this one, and the blue one represents x squared plus y squared equals 1. Now, uh, what we need to understand first is what a control line is. Well, first off, yes, with that, what a control line is, you might be wondering. Uh, so an intuitive idea of what this is. Imagine you got this red graph with a plane. I'm gonna highlight it with yellow. So imagine here you have like this this yellow plane along the xy plane, but the difference is that it's at whatever height you want it to be at. And for example, imagine that this is a z-axis. Imagine you got this same function in so many planes, and what you're going to do is like to draw the intersections between your plane and your graph and put them all together. So for example, the intersection with the yellow one, I drew a while ago, will be like this. This is like the intersection. And how would it look like? What would it look like from above? So, for example, let's get rid of this one. So this is what it looks like from the above, and if we draw that intersection with the yellow plane, it would look like this. So say we are at this height, and we can do it with imagine we do more than one plane, and we draw its intersection with the red graph. So it would look like this, and these white lines represent contour lines. So that's the main idea of uh, multivariable optimization, because when we want to optimize a function on a certain set, or rather a constraint. In our case, this blue function, the circle, is our constraint. It's constraining the the maximum quantity we want to get. So in this case, I'm gonna get rid of those control lanes. What we need also to understand the idea of a gradient, but I'm not going to explain that in this video. So supposing I'm gonna assume you already know what a gradient is. So imagine you withdraw the gradient of both functions. Here we have, let's say, this yellow arrow represents the gradient of the red function at this point, and look at this. Look that the yellow one also, its gradient points in the same direction, but it not necessarily means they're the same length. So we can say they're proportional. And you could think, why don't we just set the original function to this function? We could just say, oh, f of xy is equal 1, and 1 is equal x squared y, and we have also this function 1 is equal x squared plus y squared. So we have a system of equations, and you could solve for x and y, but that's not how it works. Why? Because when we are asked to maximize a function, a multivariable function, what we are looking for is at what points the contour lines are equal, to the constraint line. So, or rather, at which point they are tangent to each other. And this contour line is tangent to this circle over here. So if you have a better look, you will notice that there are not the same height, because this blue one is a little bit below from the red function, and therefore a little bit above from this contour line of the white one. So that's why we can't set the functions equal to each other. And how can we determine this maximum point we are looking for? Well, remember I said the gradient of the blue circle, the blue arrow, is proportional to the yellow gradient of the red graph, the red function. So we can set the gradient of our function f is equal to the gradient of our constraint. I'm gonna represent it with a g, but we said they're proportional, not necessarily the same. So here we introduce the idea of a Lagrange multiplier, represent with the Greek letter lambda, and that's basically the idea of how we can maximize this point. And in the next video I'm gonna solve this particular problem that I wrote over here. So goodbye.